The problem says, determine the rate law, find the orders for the stated reaction. The rate law is defined as K to the 1 times X B1 Y. In order to determine the orders of each reaction, we need to use the information of the experiments. To determine rate of A, we're gonna use experiment 1 and experiment 2. And that will be K A1 to the X B1 to the Y over K A1 of experiment B times B1 to the Y. This will equal K over 0.004 to the X 0.002 to the X 0.09 to the Y and 0.09 to the Y. Like you can see, this and this and this and this cancels, and then we have the rates of each one, which is 0.047 over 0.012, and then we're left up with 0.004 to the X over 0.002 to the X equals 0.047 over 0.012, which equals 2 to the X 4, and then X is equals to 2. Therefore the order of A is second order reaction. We're gonna do the same to solve for the rate of B. But this time we're gonna use experiment 1 and experiment 3. We use that because they have the 0.004 in common, and therefore something is gonna be able to cancel out. Then we repeat the process. I like writing everything down so I won't get confused. And then we plug everything in, which is 0.004 to the X, 0.090 to the Y, and K 0.004 to the X, and 0.045 to the Y. And then this cancels, and our rate is 0.047 over 0.047. We're left with 0.09 to the Y over 0.045 to the Y. It's equal to 0.045 0.047. And then this is equal to the y. It's equal to 1. Therefore, the order of y will be 0 because everything raised to the 0 power will equal 1. Therefore, the order of b is a 0 order reaction. Then we plug in back into our rate law formula using any of this data that was given and the order reactions that we got. Therefore, if we use the first experiment, 0.047, it's equal to K, 0.004, and then the reaction for X and the reaction of Y. The reaction of X was second order, and then for Y, it was 0 order. And this way we cancel for K, which we end up being K equals 2937.5. And then our rate law ends up looking like 2937.5 times A to the second order times B to the 0 order. And that's our answer. The next problem says, which would be the equilibrium reactant Kc for the reaction? Kc is equal to products over reactants. But we cannot include solids, and we cannot include liquids. So then we go back into our equation and we see that we have two solids which cannot be in the equation. Therefore, our equation, it's going to look, the only products that we have left is H2. It's going to look like H2 to the fourth over H2O to the fourth equals Kc. The next question says, a reactant in 0 order depletes to 0.03 moles from 0.46 moles in 0.65 hours. Find the half time. The formula for the concentration time for a 0th order reaction, it's AT is equal to negative KT plus A to the 0th. And our half-time equation, it's A naught over 2K. Now, having those equations, we just need to plug everything in. So it's saying that it depletes 2.03 moles to 0.46 moles. Therefore, this is going to be our A naught, what we started, right? And therefore, this is going to be our AT. So plugging into the first equation, we have 0.03 is equal to negative K. But for time, this needs to be in seconds. Therefore, this time we need to convert it. And for that, we use our regular conversion, which is 0.65 hours, 60 minutes, 1 hour, but we need to convert to seconds. Therefore, 60 seconds, it's 1 minute. And this equals 2,340 seconds. And this is what we're gonna use here. Plus our 0.46. And solving for this equation, we get that our K is equal to 0.0000184. And then we can use our half-time formula. And A now we had said it was 0.46 over 2 times 0.0000184. And our half-time is 1250 seconds. And this is our final answer. The next question says N2O5 is reacting at a rate of 0.27 in the formation of nitrogen dioxide and molecular oxygen. What is the rate that NO2 is being formed? So first we need to write our equation down, which is N2O5 this associates into 4NO2 and O2. Then balancing our equation, we see that we need a 2, and then we use our formulas, which this will look something like this because the 2 goes to the bottom, and then our concentration over change in time, it's equal to 1/4 2 plus concentration into, and then we need the rate that NO2 is being formed. Therefore, the reacting rate of N25 is given, so we can use this to solve for NO2. It's equal to 1/4, and we're changing time, and then we multiply by 4 on both sides, and we end up having that our rating NO2, it's equal to 0.054 ms. The reaction to A plus B dissociates into 4C plus 2D is found to be first order overall and 0th order with respect to A. So first order overall. First of all, we need to write our rate equation, which is K to the X times B to the y. It says that it's first order overall. That means that both orders need to equal 1. So that means that x plus y need to equal 1. So it says that it is 0th order with respect to a. So then it's equal to k. 0 order to respect to a, and he needs to be 1 ordered overall. So that means that y is 1. And that it will be our rate equation because 0 plus 1 is first order overall. So that means this is